So good morning, everybody. Welcome again to the last day of the conference. It is my pleasure to introduce Mr. Dr. Jafar Rezaei. Jafar holds the position of Associate Professor at the Faculty of Technology, Policy and Management at Delft University of Technology in the Netherlands. His research focuses on behavioral decision-making methodologies and their applications across various domains, including supply chain management and the health sector. Jafar Rezaei is widely recognized for his contributions to the development of several decision-making methods, notably the best-worst method, which has emerged as a mainstream approach in the field of multi-criteria decision-making. In addition to his research, he teaches courses on supply chain management, logistics, and multi-criteria decision analysis. Furthermore, he serves as the editor-in-chief for the Journal of Multi-Criteria Decision Analysis, a preeminent journal in the MCDA field. Well, Jafar, the floor is yours. Thank you for coming.
Thank you very much, Monica, for inviting me and also for introducing me. And thank you, everyone, for being here today. I recognize many faces here. Some I have worked with from Journal of Multi-Criteria Decision Analysis or others. So it would be an honor for me to give a talk on best-worst method. So I'm sharing my slides first. So you can see my slides?
Yes, perfectly.
Yes? Okay,
yeah.
Okay. Thank you very much. So this presentation is about best-worst method. It is a method I developed in 2015, and since then I have been working on together, of course, with some colleagues and friends. I was, and I'm still a fan of AHP. I think one of the best and most widely used methods in the field of multi-criteria decision-making with many applications. And actually, the method that I'm talking about is also very well connected to some basic ideas of AHP. So first, the process of multi-criteria decision analysis. I think this is a very nice picture by Belton Stewart, and I'm sure that you're familiar with this, but I still want to present it because I want to mention something about the process, which starts actually from identifying the problem or issue. So we need to first understand the problem, and there are many methods in literature for problem structuring to identify the core issues, the values, different stakeholders, different alternatives, different objectives that different stakeholders have, and usually we translate these objectives to some evaluators or criteria or attributes in order to measure or evaluate alternatives with respect to these objectives. And sometimes we also look at the uncertainties, and then we see which model we can use for the problem, and more specifically in the context of multi-criteria decision analysis, we look at alternatives and criteria, which are used to evaluate the objectives. And then we try to find a solution for the problem. The problem is sometimes a choice problem, sometimes a ranking or sorting problem, and when we then, after that, we do some sensitivity analysis to check the robustness of the outcomes, and finally developing an action plan. So as we are, all of us are familiar with this process, it's very complicated, and if we want to do it properly, it takes a lot of time and energy. It is very interactive. It's about discussing the issues between the analyst and the actual decision makers to understand their preferences and to model their preferences. and see how we as analysts can help decision makers to make more informed decisions. So again, this is very also important to understand, and we are also all familiar that the whole process is based on human judgments. So at each step, from identifying the objectives, uncertainties, alternatives, objectives, attributes, everything is based on the judgment of the decision makers. So there are many studies in literature about the biases that we as human beings have at each step of this decision process. For example, most of the time we are not able to, without the help of some experts, we are not able to find all the relevant objectives, or we cannot easily find the attributes to evaluate these objectives, or sometimes we have just a very limited number of alternatives and we need some support to broaden our perspective to look for more alternatives. Or sometimes the stakeholders, some of the most important stakeholders are not involved in the whole decision process, and then there is no guarantee that we can go for an action plan. So there are many judgments in this process, and there are a lot of studies also in literature of psychology showing that these judgments are usually biased. There are many biases in the literature of decision making, and here I think you're familiar with this cognitive bias codex. It is updated and it has a very long list of biases that we have. Some of them are cognitive biases, some of them are motivational biases. Cognitive biases are the errors that we have in our judgment or in our reasoning thinking, and that's part of our brain most of the time. We cannot get rid of those very easily, and emotional biases are the biases that affect us when we are in a particular mood. One of the most important biases that I have studied a bit in the context of multi-criteria decision making, and it is very well studied in the broader context of decision making, is anchoring and adjustment bias. And this is a bias that first was introduced by Tversky and Kahneman in 1974. They have also, of course, mentioned that there have been some studies before, but these two are the first to formulate this bias. And the basic idea here is that when we make judgments, our evaluations are usually biased towards the first piece of information that we receive or we create. We have external anchoring bias and internal anchoring bias. So this is, I believe, the first experiment that has been done in this regard for anchoring and adjustment. So basically what they did, they showed the first multiplication to some students, and they asked them to just estimate it within 5 seconds without any calculator. And they asked other students to estimate the second one. And most likely, if you are not even familiar with this experiment or this paper, you can guess that the result of the first multiplication should be smaller than the second. And actually, the mean answer for the first multiplication is 512, while for the second one is 2,250. The reason is that when we start doing this and we have limited time, we start with 1 times 2, 2, 2 times 3, 6, 6 times 4, 24. We do not have enough time maybe to do the rest. So far, we see that the result is relatively small, and then we provide a relatively small estimate for the full multiplication. While students who go through the second one, they say 8 times 7, 56 times 6, 300 something, and then it's already a very big number so far, and then they provide a much bigger estimate for the second one. So usually we have anchors, and in general we have low and high anchors. So for example, in the condition 1, we have a low internal anchor, and we call it internal because we do this multiplication in our brain, so we make that. And for the second one, we have a high anchor. So because the first result, which is coming from multiplying the first couple of numbers, is big, so we call it a high anchor. So when, as a human being, we encounter low or high anchor, we try to adjust from that. But usually this adjustment, as has been mentioned by Tversky and Kahneman and many more, this adjustment is insufficient, and that's why they call it anchoring and adjustment bias. There are many, many other very interesting experiments in literature. For example, some students have been shown a line which is less than, I think, 89 millimeters, and they ask the students to extend the line such that it becomes 89 millimeter. And some other students, a taller line, and they have asked students to cut it such that it becomes 89. And the result again is in line with this, which means that the first group who has started with lower or a smaller line, they ended up with a number which is less than 89, and the second group who has started with a longer line, they ended up with a longer line, more than 89 millimeters. In the context of MCDM, there are not many studies actually to look at these biases. And this is one of the studies that I conducted a couple of years ago. It's not a fully multi-criteria decision-making problem, but I wanted to look at least a couple of items. So because in literature, usually there are 2 items. So what I did, and I need to highlight that this is not a multi-criteria decision-making problem, but I wanted to make a gap between the existing studies and MCDM, and then after this, I have done a couple of more studies, which is in the real context of MCDM. Here, I showed this map to students, I asked them to just estimate the size of these countries using mean 10, some call it, or SMART method. So if you're familiar with the SMART, it is a relatively simple method in the context of multi-attribute value theory. And usually we start with the least important attribute. We assign it number 10, and then we go and assign a bigger number to the second attribute, etc., until we assign a number to the most important attribute. There is another version which is called max 100 or swing, which starts with the most important attribute. So this time we assign 100 to the most important attribute, and then we assign a smaller number to the second most important, etc., until we end up with the least important attribute. So I was thinking that, okay, we have this SMART, we have swing and min max 100, and probably it is affected by anchoring bias, because when we start with 10 and we assign bigger numbers to the larger countries, probably there is a tendency of people to assign, of course, bigger number to larger countries, but not sufficiently big. On the other hand, when we start with the largest country and we assign it 100 and then we go downward, we assign smaller numbers to the smaller countries, but probably that is not sufficiently small. So I gave this map to one group of students and I asked them to follow min 10 and another group of students to follow max 100. And the result, as you can see here, so the black line is actually the actual size of these countries, and the red one is the estimated size of these countries. So as you can very clearly see, when we start with the smallest country in this map, which is Luxembourg, and we ask students to assign 10 and then go assign a bigger number to other countries, bigger numbers. They assign bigger numbers, but they are not sufficiently big. On the other hand, when they start with the largest country, which is Belarus here, and they go downward, they assign a smaller, but not sufficiently small. And this is just another confirmation of this bias in literature, but this is a little bit different because here we have a couple of items, not only two. And I intentionally selected this case because, as we all know, in the context of multi-attribute decision-making, we do not know about true preferences, about the actual preferences, or it's very, very difficult. So I thought that, okay, in this case, we have the size of the countries, and then we have the actual estimate, and we have the estimate, and we have the actual numbers, and then we can make a comparison. Okay, but in the context of SMART and Swing, we use these scores, and then we normalize them in order to get the weights. And although the difference between black and red is really large, when we follow the normalization, the results is not the results of the two, the actual and the estimates are not so big, but still there is a difference between the normalized scores when we follow the actual size compared to when we follow the estimates. So this is actually one of the basic ideas that leads to development of best-worst method. So in the literature of anchoring and adjustment bias, there are a couple of mitigation strategies. And why mitigation strategy? Because some studies actually show that this bias, like some other cognitive biases, are part of our brain, which means that we cannot easily get rid of them. There is actually one study that made two groups of students, and they first taught one group how anchoring bias behaves, etc., etc. So the first group now know a lot about anchoring bias, and the second group they do not know, and they did an experiment after that, and the results are really similar, which means that even by learning we cannot improve some of these biases, including anchoring bias. But there is one promising mitigation strategy, which is counter anchors, which means that if we provide two or multiple anchors which behave in opposite direction, of course, we as human beings or decision makers cannot get rid of those anchors, but because there are two, for example, and they behave in opposite, when we use them both in a particular method or assessment, there is hope for mitigating this bias. Okay, so I talked about anchoring and adjustment bias, and I talked about this promising mitigation strategy, which is counter anchors. Now I start a presentation about the method, and then hopefully you connect the link between anchoring and adjustment and the steps that we follow using this method. So in the first step of BWM, like AHP and many other methods, we ask a decision maker, or we support a decision maker to find the objectives and translate them to some attributes. So here we have a list of attributes for a particular problem. For example, in the case of buying a car, we can have quality, price, comfort, safety, and style. So we have n attributes or criteria to be identified by the decision maker. And in the second step, we ask the decision maker to identify the most important attribute and the least important attribute. And we call them best, the most important, and least, the least important one. And that's why the method is called best worst method. So these are actually the two anchors, a high and a low anchor. And then the decision maker conducts a pairwise comparison between best and all the others using the fundamental scale developed by Satie, numbers from 1 to 9. So we have comparison between best and the first attribute, the second attribute, etc., etc. We also do similarly between all the other attributes and worst. So far we have two vectors of pairwise comparison between best and others and between others and worst. The criterion here is the consistency criterion, which means that we try to find the unknown weights such that the comparison between best and J multiplied by the comparison between J and worst is equal to the comparison of best to worst. So very similar to what we also use in AHP. And in order to find the optimal weights here, of course, we know that it is ideal to expect decision makers to be fully consistent. That's why within the context of BWM, we try to minimize the maximum deviation between the provided pairwise comparisons for the two vectors and the associated weight ratios. So the weight of best to the weight of J, we expect it to be equal to the comparison between best and J, and similarly the weight of J to the weight of worst ideally be equal to the comparison between J and worst. And as we know, it's almost impossible to get full consistency. We minimize the maximum differences. And therefore, we formulate this min-max problem, which is minimizing the maximum of deviations, having the sum of weights be equal to 1 and non-negative weights. Then we have this problem that we can translate it to model 2, and then we solve it, and we get the weights. Here we have also developed a consistency ratio for BWM. We have in literature there are many different models, optimization models for BWM, and we thought that maybe it's good to develop a consistency ratio which can be used for all different models, optimization models. We call it input-based consistency ratio, which means that after collecting the data, we can measure the consistency of the pairwise comparisons regardless of any optimization model we can use. So there are thresholds for different number of criteria. Of course, we start from 3 because 1 is meaningless here, and 2 leads to always consistent results. And for a scale, also we have 3 to 9. So a scale here means that the maximum number that has been used in the pairwise comparison system. So these are the thresholds that when we collect the data, we can check the consistency ratio and compare it with the thresholds, and if needed, we can ask the decision maker to make some revisions. Okay, so in the beginning, I talked about anchoring bias, and I also mentioned that counter anchor, or consider the opposite as it's also called in literature, is a promising strategy for anchoring bias. So we have best to others. So here, best is an anchor, and we have others to worst, and worst here is an anchor. And because the behavior of these two reference points is completely different and in opposite direction, when we put them both together in one optimization problem, there is hope to mitigate this anchoring bias. So there are a couple of studies where we have shown that actually it works like that, and I will come back to that with some results a little bit later. So that was the BWM, the very basic version of 2015. So later, we also developed BWT, best worst trade-off, which is a kind of a variant of a trade-off procedure within the context of MAVT. So, and of course here, as there is always discussion between methods that are considered in the context of MAVT with some other MCDM methods that, for example, in trade-off procedure, we consider the range of the attributes, but in AHP or in BWM, we do not. So I do not want to comment on that, but we wanted to develop a method that also considers these ranges of attributes. So as you probably are familiar with trade-off procedure by Keeney and Raifa, again, here we have a set of attributes, we have a set of alternatives, and we need to evaluate these alternatives with respect to these attributes. We elicit the value functions, we elicit the scaling constant or the weights of the attributes, and hopefully if some conditions hold, then we can use an additive value function, or if we do not have some conditions, we can also use some non-additive value functions. But my focus here is not on the value function elicitation, but on the weight elicitation or scaling constant. In the context of classic trade-off procedure, when we know the range of each attribute by having a look at the list of alternatives, we make different hypothetical alternatives, and we ask the decision maker to make a comparison. So for example, if we have 4 attributes, we put the level of 2, 3, 4 on the left-hand side picture to the minimum, and criterion 1 to the maximum. Maximum here means the best value, assuming that they are all monotonically increasing. And then for the second hypothetical alternative, we put the value of C1, C3, C4 to the minimum, and C2 to the maximum. And then we ask a decision maker which one she prefers. If she prefers the left-hand side to the right-hand side, then we conclude that C1 is more important than C2. We can do this for all the other hypothetical pairwise comparison to see which one is more important than the other one. When we know the order of the importance of these criteria, then we can go and continue asking some indifference relations. So here we assume that C1 is more important than C2. Then we make this hypothetical alternative to the right, which is C1, C3, C4 to the minimum and C2 to the maximum. And then we ask the decision maker to increase C1 to a level such that she is feeling indifferent between these two alternatives. When we have this level and we can continue asking questions about the rest, then we can determine the weights by solving a very simple system of equations, and then we get the weights. So this is basically the basic idea of trade-off procedure. And usually in the context of MAVT and trade-off procedure, we compare the best attribute to all the others. Then we thought that, and here we have n-1 pairwise comparison. We thought that, okay, what if other than comparing this best to everything, we also compare everything to worst attribute? Maybe the results are different because, again, because of this anchoring and adjustment bias. And we thought that, okay, maybe an idea would be to do both of them. So to identify the best attribute, comparing it to all the other attributes, the same for other attributes to the least important. Then instead of this set of equations, we have two sets and we can put them into an optimization, because we cannot use a system of equations because there might be many different solutions for that. So the steps of BWT, best worst trade-off, we have a set of alternatives, attributes, and then we have a consequence vector. We elicit the value functions, which is not the focus of this presentation. And value functions are the functions that actually translate the actual score of alternatives to numbers between 0 and 1. And they can be monotonically increasing or decreasing. So here, for example, we have two monotonically increasing value functions. The left one is linear and the right-hand side is nonlinear. But basically what they do is to translate the numbers on the x-axis to the y-axis, which is a value between 0 and 1. Then we identify the best and worst attributes. Similarly to the trade-off procedure, we can define some hypothetical alternatives and ask the decision maker to do a pairwise comparison to see which one is more important and which one is actually the most important and which one is the least important. And then we can do actually a pairwise comparison or pairwise comparison to find the indifference relations between best and others, which is 100% similar to trade-off procedure, as I explained before. But on top of that, we also do a pairwise comparison between, not against pairwise comparison, indifference relations between all the other attributes and the worst attributes. So as we clearly see, the indifference relations here is some amount of best to the full amount of any other attribute, of course, because best attribute is better than all of them. So we do not make a trade-off between the whole amount of best, but some amount of best to the whole amount of others. And similarly, for comparing everything to worst, we make a trade-off between some amount of J to the whole amount of worst. So when we have these numbers, then we can use the reciprocal of these numbers as a kind of pairwise comparison. So imagine that here, half of the amount of CK is being traded off with the full amount of worst. Then it means that this criterion is basically 2 times more important than the worst attribute. If 1/3 of this attribute is being traded off with the whole amount of worst, then it means simply that it is 3 times more important than worst. So then we can convert these indifference relations to a kind of pairwise comparison. And then we can form an optimization problem like this, again, with minimizing the maximum of deviation between the pairwise comparison between best and others multiplied by the weight of criterion J and the difference with the weight of criterion best, similarly for worst. And then we have this optimization problem, which is linear, and it leads to a unique solution. Okay, so that was about BWM and BWT as 2 versions of BWM. There are a couple of other versions, but these 2 are very different from each other. I mean, one is in the context of conducting pairwise comparison, and the other one is based on indifference relations or trade-off. So in order to test if using one reference point or one anchor is different than the others, we did some experimental analysis. And hypothesis 1 here says that weights calculated based on best to others vector only are biased towards the best criterion, which leads to higher weight for the best and the worst criteria and lower weights for the other criteria. So best, if you think about, if as a decision maker you're thinking about your attributes and you consider the most important in your mind, this works as an anchor, because when you compare it to all the other criteria, you have a tendency to underestimate the importance of others, because you are thinking about the most important criterion of your decision. Similarly, when you are thinking about the worst criterion, there is a tendency to assess the other attributes much more important than what they should be. And when we put them together, we have hope to mitigate this. So we collected data from, these are some studies. So this is one study with 50, a sample size of 50. So this is actually the result of the original paper 2015. And the orange line here are the weights based on using only others to worst vector. The darker blue are the weights based on only best to others vector. So orange and darker blue based on only one vector. And the lighter blue actually here is based on BWM, so putting them together. And as you can see here, for the most important attribute, the weights coming from BWM is somewhere between when we use only the best to others vector or when we only use others to worst vector. So statistical analysis also show that there are some significant, statistically significant difference between these findings, the weights. This is another problem. This is a baggage handling problem here at Schiphol. We have a sample size of 147 passengers. So we basically actually collected data to using BWM, but we did it later. So we just separated the input to two vectors, only best to others, only others to worst, and we compared it to the results of best worst, and you see similar pattern. Again, the weights coming from BWM lie in between the two extremes of best to others and others to worst because they are anchored. And this is also a very recent study which hasn't been yet published. So this is based on best-worst trade-off. Here we have a sample of 240. And here we did it based on the trade-off procedure of Keeney and Raifa, which is actually based on one vector n-1 indifference relations. And we compared it to the result of BWT that puts these two vectors together and uses an optimization. And again, you see here that the results, the blue one, which is BWT, lies in between the two extremes. So as a conclusion, although our judgments or preferences are biased, and many studies show actually that we cannot get rid of them, we could devise methods to mitigate these biases. So that is one hope that we have, and this is actually based on some psychological studies. So in psychology, usually, and in the context of decision making, in the field of psychology, there is nothing about methods, or most of the time it's based on some descriptive studies. It's not prescriptive. But here in this setting that we are working on prescriptive methods. So we can actually do something to help decision makers to find outcomes which are less biased at least. And here some references for best worst and some of the studies actually that we did to show these debiasing mechanism of BWM. Thank you very much, and I would be happy to take questions.
Okay, sorry, I was mute. Perfect. So thank you very much, Jafar, for your insightful presentation. I would like to ask people of the audience if you have questions to the best worst method author. Anybody wants to ask Jafar anything?
I think
Enrique
Birsen already has raised her hand.
Enrique, Birsen so far. Okay, Enrique, go ahead.
Jafar, very interesting presentation. I wonder if we have all these methods, including yours. Do you have a sense for a specific kind of problems in which this approach is mostly recommended? Like there is a type of problems in which this approach is particularly useful?
Sorry, I didn't understand the question very well, Enrique. Sorry. So you mean particular context or?
No, I mean if this type of approach would be recommended for any particular set of problems in which this is definitely the best approach.
For set of?
For
set of problems.
Any set of problems or decisions for which this approach is particularly good.
Yeah, I mean, so compared to other methods, you mean? I think if we, yeah, I think in general, BWM can be used, I mean, the original version can be used when we want to have some understanding of the importance of the attribute for decision makers, but we can use BWT when we want to very clearly incorporate the range of the attributes. So I think, for example, here we can use the results of BWM. We cannot use the results of BWM in the context of MAVT, but we can use the results of BWT in the context of MAVT, because in the context of MAVT, the additive value function that we use is based on the trade-off, and it's not based on the intrinsic importance of the attributes. So, yeah, I hope this is an answer to your question.
Thank you very much.
Yeah, thank you. And good to see you, Enrique, by the way.
Me too. Me too.
Birsen?
My question is, first of all, of course, I think no need to say anything. It was outstanding presentation. It was excellent.
Thank you very much.
I'm wondering if I can use this methodology if there are dependencies among the criteria.
Yeah, that's a very good question. I think we have a version of the method which is called non-additive best force method. I think it's published in Journal of Transactions in Operations Research. And when there is interdependency, we recommend that version to be used, which actually handles also the interdependencies. But the original version doesn't.
Yeah, anybody use it other than use if there are some dependencies? Any one of us? I know I didn't. Because yeah.
I have a question, please.
I have one more question. Then I think.
Juan Antonio, wait a second. Birsen finishes, and then you go ahead.
Okay, no problem.
Do you do some sensitivity analysis after you find the solutions? Because the conditions might change, and how the results will change if conditions change.
But what do you mean by condition, Birsen?
Situation changes, importance changes. Usually, that is what we do. I think you are familiar with the HP. We always do sensitivity analysis. We don't just say this is the best alternative, but before doing that, we look at if there are some.
Yeah, definitely. Always, I think a good application of any MCDM method, including BWM or ASP, should be also sensitivity analysis. Yeah, definitely. And we also have another version of BWM which is called Bayesian BWM. This is also used for group decision making, and also I think that's very unique in the context of MCDM, where we also assign a cradle ranking to the attributes. So the final outcome, for example, for the mean of the most important attribute for a group, if it's 0.42 and the second is 0.40, we do not directly mention that the 42 is greater than 0.40. We assign a cradle ranking to that, which is a number also between 0 and 1. So it's a kind of confidence to that superiority of the weight of one alternative or attribute to the other one. But yeah, definitely, we use also sensitivity analysis. I think, but changing the condition can also mean that if we consider time, so if I do some assessment today, the outcome might be different than when I do it next week, or when I do a pairwise comparison today for a problem of today, the results would be different than when I do a pairwise comparison for something that should be done next week. So I'm supervising a PhD candidate who is also working on time preference, and we have conducted a couple of experiments, and we have found very interesting results that when in the context of decision making you have alternatives to be evaluated with respect to different attributes, that some have immediate consequences and some future consequences. For example, when you buy a car, you have to pay the price immediately, assuming that you pay the full price, then price is an attribute with immediate influence, while, for example, insurance cost, so you pay over time. So you pay, for example, every month or every year, and you will pay it during the next couple of years. Or maintenance cost, which is more even important, you do not have any maintenance costs at the time of purchasing a car, but you expect to have some maintenance costs in the future. So people have a tendency to assign higher weights to the attributes which have immediate consequence and lower weights to the attributes which have consequences in the future. And that is also very interesting, I think.
Thank you very much. I have some more questions, but I would like to leave the floors to some other audience. I think they have the right to ask questions as well. So thank you very much.
Then we can go back to your questions if you want, because we have time. So we can go back
that is why I asked so many questions, because I can see that we have time. So I think, and I looked at number of participants. So okay.
Okay.
So, but I can still wait.
Juan Antonio, go ahead.
Thank you. First of all, Jafar, it was amazing, your presentation. I admire about how can we learn from each other. In your workshop, you mentioned that the best-worst method effectively mitigates behavioral biases commonly found in multi-criteria decision-making MCDM problems. Given the inherent complexity and subjectivity in human decision-making, how does BWM specifically address and reduce these biases compared to the other MCDM methods like the analytic hierarchy process? Additionally, could you elaborate on any empirical evidence or case studies that demonstrates BWM's superiority in achieving more consistent and reliable decision outcomes?
Okay, thank you very much. Very, very good questions. I think with respect to subjective outcomes, I think this is something that we cannot easily comment on superiority of any particular method unless we show by maybe, I don't know, some experiments, or the way that, for example, I did for SMART and SWING for estimating the size of countries where we have the true values, whether a mitigation strategy can work or not. So there are a couple of studies actually that we show that there is anchoring bias when we use N-1 pairwise comparisons. For example, in the context of trade-off procedure, it is very clear to see these bias, this anchoring and adjustment bias. And there are actually a lot of studies by Tversky, Kahneman, and many others for reference dependency, loss aversion, prospect theory, which show that actually the evaluation or the judgment of decision makers are significantly affected by reference points. So when it comes to AHP, we conducted a study applying, I think, 4 different methods: AHP, BWM, point allocation, SMART, and SWING. And we checked equalizing bias. So we had a very simple experiment, and we wanted to see which method actually leads to more equal weights. And interestingly, we found that AHP and BWM behave relatively similarly, and the other 3 have significant equalizing bias. So there is no big difference between the 2. Yeah. Did I answer your questions, Juan?
Yes, very clear and loud.
Yeah.
I hope that we can collaborate in the future. Thank you.
Yeah, sure. Thank you very much.
Okay. Anybody else wants to ask questions?
Yeah, I have a question.
Luis,
yeah.
Okay. Luis Bojorquez from Mexico.
Thank you. This is very interesting, the way you address the anchoring and biased. But I would like to know your experience in applying this your approach in group decision making, especially with large group, and because I've been working on geospatial multi-criteria evaluations assessments with many in rather large groups in participatory or analytic deliberation, whatever you want to call it. And I can see the effect of anchoring, especially in the development of the value functions. So have you have any experience how to apply your approach in this kind of setting?
Yeah, we have applied to a couple of group decision-making problems. Most of the cases are logistic companies here in the Netherlands. So basically, what we do is so most of the time is connected to also to some problem structuring workshops. So we first want to have a good understanding of the problem, but when it comes to BWM, there is usually a discussion, and we go usually for the sharing approach by, I think Belton has provided 3 different approaches for group decision making, which one is sharing, which means that we try to see if people can agree on the most important and the least important attributes, and to follow the pairwise comparison. And if not, of course, we can do it also separately. I mean, in subset of groups or even individually.
Okay, thank you.
Thank you for the question.
Okay, now we have Sergei Kadenko. We have some questions also in the chat, but I will read them at the end.
Yes,
Sergei, I don't know how to pronounce it. Go ahead, please, Kadenko.
Hello?
Hello, hi.
Can you hear me?
Yes.
Yes.
Hi. First, I'd like to say that it's been a pleasure to have you as a reviewer of our paper published in the Journal of Multi-Criteria Decision Analysis this year, this May. And second,
Congratulations.
my question is, yeah, thank you. I mean, we got the best reviewer we could hope for, really, honestly. It's like
Okay.
it was a great pleasure and a great surprise to learn that you would be the editor-in-chief of that very issue, because it's very like you know the subject better than anyone probably. So I would like to ask you, what is your attitude towards the issue of redundancy of comparisons? I mean, you have 2n-3 comparisons where each object is compared to the best one and the worst one only.
Yes.
So do you how do you know that we might not need more comparisons to like corroborate the credibility, the consistency of the comparisons we already have? I mean, it's an open question. I'm thinking about it myself, and joined with my colleagues. It would be nice to hear your opinion.
Yeah, okay. Thank you very much for the very good question. Actually, I don't know. The simple answer is that I don't know. I don't know if we need to have more pairwise comparison. I definitely go not for less. I think less than having 2 vectors. Yet to me, it doesn't make sense. But more than that, I don't think that there will be a problem necessarily. I mean, we have compared the results of BWM to AHP, and I have seen also several other papers that have compared the results of BWM to AHP, and the results are similar. So you can argue about whether the results are fine or not at all. That's a different question, right? But they are similar. which means that if they produce wrong or right results, they behave relatively similarly. Then it means that, I think it means that, yeah, having a little bit less than a full pairwise comparison necessarily do not lead to different results than what we have for AHP, for example. But in terms of redundancy, I think the idea that I used for this BWM was very simple. I thought that, okay, when I want to, as a human being, when I want to do a pairwise comparison, I have A and I have B, and I want to do a pairwise comparison. Probably I cannot do this pairwise comparison. For example, I'm just comparing which student is taller than the other one, right? Okay, I go to a classroom and I look at two particular students to see which one is taller than the other one. So I was thinking that, okay, I cannot do this pairwise comparison only if I know about the tallest and the shortest student in this classroom. Otherwise, I cannot do this. I cannot do this. If I look at two students and I see that one is taller than the other one, and if I have this wrong perception that actually this is the tallest, I might have a tendency to assign a 7, 8, 9, something like that in pairwise comparison. But when I see that there is another student who is actually much taller, I might change my pairwise comparison. And that is not sufficient still, because I should also know who is the shortest one. And if from the very beginning I know who is the tallest, who is the shortest, and I know the maximum of the scale that I'm using here is a 9, then I can consider that for comparing the tallest to the shortest, and I have a better understanding of the other pairwise comparison. So that was my basic idea when I started thinking about this method. And I thought that, okay, if you give me some attributes or some alternatives, and you ask me to do a pairwise comparison, I cannot do it without having these two reference points. I can do it, but probably if I do it and later I see that, okay, there is another alternative which performs much better, I probably go back and revise my previous pairwise comparison. So in order to avoid this revising of my previous pairwise comparisons, if I know it from the very beginning, I don't know, probably there is a better chance to do it more appropriately.
Yeah, thank you. And have you thought about like stability to errors, simulation type experiments, maybe?
For what?
Stability of the best worst method to expert errors, where you well, you can generate a set of priorities, then you can like fluctuate it, add some noise to the matrix, and then calculate new priorities according to the deviated, fluctuated, noisy matrix, and then calculate the difference. Have you tried to perform any such experiments in any of your numerous papers?
No, we haven't done so, no. But it could be, I think, an interesting idea.
Okay, yeah. Can I just write you a message? Okay, thank you. If I have more questions.
Yes, please. Yeah, I would be happy to receive your email.
Thank you. I might write you an email if something else comes to mind. Thank you very much.
Yeah, please. Yeah, I would be happy. Yeah, thank you so much, Sergey.
Okay. Birsen, I think she has more questions. Go ahead, Birsen. You're muted, Birsen.
When we have quite a few criteria, we usually group them so that we can reduce the number of pairwise comparisons. Can we do it with the best method?
I think it's possible, right? Yeah. Yeah, I think we can do it. Yes.
Yeah, because it is very important. For me, I'm not interested in new methodology. I'm interested. My innovation is application, and most of the applications, as you know, you teach supply chain management as well. There are lots of criteria, and usually they are even grouped them. And it comes as a group them. So how can I solve these kind of problems if I want to use best method?
Yeah, I think that's so even if you group them, I assume that then you have a label and a concept and a meaning for that. Otherwise, it's a very difficult job to do paperless comparison. But if that group still is meaningful to a decision maker, then to me it would behave similarly to when you do not do it. I mean, because so you go upward. So you mentioned that you group some criteria to make a bigger criterion. But if you think the other way around, that we usually go hierarchically down to make some sub attributes, and then we consider different levels even. I think that is most of the time endless, because even for very specific attributes, you can still consider some sub-attributes, but usually we stop at a level because it doesn't make sense. It cannot have the discrimination power to make any distinction between the alternatives. We just stop, and because we cannot handle it also mentally. So that to me would be the same thing. So then it means that if you go also in a hierarchy up, you can also combine them to a criterion, as far as it has a meaning to you. I mean, if I put some criteria together and group them, but I cannot do any paperless comparison.
Yeah. Yes. Sorry. Yes. Yeah.
But if it doesn't have a unique meaning to me, then I cannot provide a paperless comparison, because each time probably something comes to my mind which is part of that criterion and not the whole meaning of that.
Usually these groups has meaning, and sometimes some groups are more important than the others. So we have to compare. We have to do pairwise comparison these among the groups as well. Yeah.
Yeah, I understand. Yeah.
And for example, if I have a car, $20,000, the other one is $40,000, my answer will be quite different depending on the decision maker. For a student, a 20,000 car is maybe strongly more preferable than this 40,000 car. Okay, so the relationship is not twice. For example, price is twice less expensive, but I don't think I can prefer 20,000 car twice more than 40,000 car. So what do you think about it? So if you just use the numbers, sometimes my students, engineering students, they just use some numbers. They just think, okay, just put number 2 if they put numbers. But I think if you express it verbally, then, and if I ask Bill Gates, of course, in both of them are equally preferable for him.
Okay, but
so I just say if I use the HP scale for 20,000 car would be strongly more preferable for a student. If I am asking another decision maker, maybe 20,000 card is moderately more preferable. So it just depends on the decision maker. So can I handle these kind of decisions with your methodology?
Definitely. I think preferences are different for different decision makers, and definitely AHP or BWM can handle this. And so the pairwise comparison
AHP does it so already.
Yeah, and I mean, pairwise comparison, the strength of a pairwise comparison, of course, depends on the decision maker, definitely, and on the context. Yeah, sure. Yeah, that's true.
My last question, do you have a software that I can use it?
Actually,
and I mean for real life problems, not for my students, or it can be we can use a spreadsheet.
Not really. We have some codes, Python codes, MATLAB codes, one Excel solver, but not a software package. No.
We want something like super decisions or
I
something
know,
that we
yeah.
can just so that we can use. I don't think we could have used. I don't think that many people would have used AMP if there wasn't some kind of software, because we really like to do some kind of, as I say, sensitivity analysis, etc.
Yeah,
So,
exactly. Yeah, I agree with you. Yeah, but we don't have it now.
okay, thank you very much.
Sorry.
So I think
Yes.
Hania has some questions.
Hania, go ahead.
Thank you, Jafar, for your presentation. I have a question is regarding the consistency. Can you detect some inconsistency in the judgment? Is easy to detect, or because of you have this idea of the worst and the best, it's difficult to be inconsistent?
Right. And then the question is,
if it's possible to detect inconsistencies on some judgment.
okay. So actually, what we do is the way we check it is first we check the ordinal consistency. So providing pairwise comparison between best and others and between others and worst can lead to ordinal inconsistency, which means that if you look at my best to others vector, you can also make an order of the attributes based on the number. So the biggest number then shows the least important, next number, second, etc., until I go to number 1, which shows my most important. So I have an order of the attributes. And if you look at the other vector, you can also find an order of the attributes. So, and if there is an inconsistency here, we call it ordinal inconsistency, which means that even if we do not look at the cardinal consistency, there is already a bigger issue here that you can locate that and go back to the decision maker to see how that can be handled, which is, of course, somehow related to the cardinal consistency of the problem, because that is about the number that the person has used to do the pairwise comparison.
Thank you. I have some questions.
Monica, I have a small question related with Hania's question. In our case, we don't really try to, our approach is not really reduce the inconsistency. If we just use inconsistency as a vehicle to retrieve the real judgment from the decision maker minds. So we just ask the decision maker make some pairwise comparisons. If she is too inconsistent, mean if she is beyond 10%, then we ask her to revise some of the decisions. Usually this takes care of, to my experience, it takes care of. So what do you think about it?
Yeah, indeed. Yeah.
So we are not, consistency is just vehicle for us to capture the real weight, real importance, preference in the decision maker's mind. That we don't care, if she's, there should be some inconsistency. So we don't want, we can get zero inconsistency if we take just one line and make the comparison, derive all the others. We just calculate everything, and we will be 100% consistent, but we can be 100% incorrect. We didn't really, if the first one was not correct, because that is why we have these multiple comparisons in AHP or in AMP.
Yeah.
So.
I understand. In behavioral economics, there are a lot of research on indifference curves. And indifference curves are usually a very nice nonlinear convex curves for monotonically increasing dimensions. But when we have a reference point, one of the first things that is violated is transitivity, which means that, of course, if we have this preference that A is preferred to B and B is preferred to C, then A should be preferred to C. But with reference points, usually this transitivity is violated, and it is not something logical. So you cannot explain it to somebody, and that somebody says, yeah, that's fine. This is what I wanted to say. No, I think if we have this, if we study the influence of such reference points, And then if we go back to a decision maker and explain it to him or her that what we get from the numbers or the judgments that you have made, we get this finding. Is it okay? I think it's not okay to us, because if we elicit an indifference curve without a reference point, which is also something really very, very difficult, because usually we have something in our mind, even if there is no very explicit reference point. But suppose that we have a reference point, then we can see the logic of our preferences. So I think, personally, I think we can go back to the decision makers. And the idea should not be necessarily to improve the consistency ratio, to make it from, I don't know, whatever, 0.2 to 0.10 or whatever, but at least to give some feedback to the decision maker, that what we have as the outcome of this method is this. And then if there is interaction, what personally I have seen is that there is no also issue of inconsistency. If people understand the meaning of pay-loss comparison, which is also very difficult for some actual decision makers. So sometimes when we ask decision makers to use this scale for pay-loss comparison, A to B, they simply rate B. They do not do a pay-loss comparison. But if they have this good understanding, I think usually also there is no problem.
Yeah. My experience is like that. If the decision makers have real problem, and if they sincerely engage with the problem, usually there aren't much inconsistency.
Exactly.
Yeah.
And especially at least with ordinal consistency. I mean, yeah.
Okay.
Juan Antonio, you have more questions?
Yeah, thank you. I want to share about my experience and related to the topic. As the head of a lab with Bloomberg Technology, specializing in finance, coding, and artificial intelligence, with a focus on climate finance and environmental social governance indicators. How do you see the best worst method enhancing decision-making processes in these areas? Specifically, how can BWM be integrated with AI and machine learning techniques to improve the accuracy of reliability of climate finance models and ESG assessments? Additionally, could you discuss any specific case studies or projects from your lab that demonstrate the practical application and benefits of BWM in managing climate-related financial risks and opportunities?
Yeah, I think with respect to applications in sustainability topics, I think there are many studies that we have done. I can send you a list of applications. In the context of logistics, supply chain, you said climate action, not something that I can remember, not something that we have done, but I have seen some other studies that have used BWM for climate action related topics. Yeah, but I can definitely share some applications with you later if I have.
Thank you, Juan Antonio. Elena Rocco also wants to ask you something, Jafar. Go ahead, Elena.
Jafar, first of all, thank you for the presentation. But I had a question, which is, what happens if you don't know from the beginning who is the best in class or the worst in class? Because in the pairwise comparison setup, you can kind of explore the situation even if you are unsure about the best and worst criteria or the best and worst alternative. What would happen in the best worst method if you don't know?
Okay, that's a very, very good question actually, and I have thought about it a lot, and I have discussed this with many. So my answer is the following. In decision making, actually, there are generally two ways to look at the decision or to look at the alternatives. One way is what, for example, choice modelers do. So in choice modeling, for example, we have choices, which are also kind of alternatives. Sometimes they can be hypothetical alternatives because they create those choices based on a combination of different attribute levels. And then we ask decision makers to do a pairwise comparison between the choices. And the idea here is that people have this capability to compare options to each other. And from these comparisons, later they infer a regression line with coefficients, whether they are significant or not. And then they can talk about the importance of different attributes for making a choice. And we have a couple of colleagues in my department who are using choice modeling, and this is the mindset that they have. We have had a lot of discussion. They think that this is something that they discuss, is that people can compare options to each other. If I go to a supermarket, I compare actually options to each other. I compare this to that. I do not look at the color separately. I do not look at the quality separately, etc., etc. But in MCDM, at least, in almost all methods, if we exclude methods like UTA, we have a composition kind of approach, which means that we break the problem to alternatives. I mean, from top first to objectives, and then attributes, and then we have alternatives. And at least we already have this assumption in the full field of MCDM that we can compare criteria to each other in order to finally make an aggregation to find an overall value for an alternative, such that we can then compare alternatives to each other, rank them, etc., etc. So if we assume that we can compare attributes to each other, right? This is one assumption. The second assumption, if we use a scale like 1 to 9, right? And 9 means extremely more important, right? Then I can simply conclude that then I can find two alternatives where I can say this one to the other one is extremely more important. And then to me, these are the best and worst criteria. Why can't I find them? I mean, why should I start with comparing them one by one such that I find on my way, okay, which one gets actually this maximum?
I'll tell you two different thoughts. Thank you for this is really a discussion. It's not that much of a question, but on one hand, there are times that you will not know exactly, but what about if you followed some combination of the approaches, for example, that HP ratings dial, that you have an ideal best and ideal worst that would solve the problem. Even if you don't know, you could always compare with your ideal best and ideal worst until you reach the one that is the same importance with the ideal, and then it can take its rightful place in the order, right? That could be a different perspective, I guess.
Okay. What is ideal best?
In ratings, because we don't pairwise compare, in HP ratings, because we do not pairwise compare, we have in mind an ideal that we compare everything to it. So that could be also the case in the best worst method. If I do not know from the beginning what is my best, I could have a dummy, let's say, criterion that is supposed to be the best criterion and work through the process with that until you reach one of the criteria that you're trying to order, which is equally important to this ideal. And then it takes its rightful best in the group place.
Can you give me an example of ideal?
Yeah, for example, let's say that we are talking, what kind of criteria? I'll go for alternatives because I think it's probably the best way. Let's say that my ideal car is a car that is small, city car, and has an average price, okay? The first one that I compare, this is my ideal and I haven't checked yet my alternative. The first one that I put in my group is a Honda Civic. Not small, has quite. I give it a 5 and I keep it there. The second one, I'll go for European car, is a Fiat. Okay, it's a Fiat Cinquecento, which is my favorite car right now. And I say, okay, this is what I had in mind when I was saying ideal. Now this will become the best, and I can update the reordering based on this new information that I have. But I didn't know from the beginning when they showed me the alternatives that that's my best.
Okay, but I thought that
Yeah.
I thought that we are talking about attributes here. I mean, we do a pairwise comparison between the attributes to get the weights of the attributes, and then I was just trying to understand what you mean by the best attribute, for example, or so not alternative. I mean, not a hypothetical alternative as the best. I can think of that, but I cannot think of the most important attribute, which is not still in my list, and that is my ideal attribute. Why it is not? If it is
my ideal.
if it
Yeah,
is
that
the
is a good
most
point.
important attribute for me making a decision, why it is not in my list, that I should consider it as an ideal, as a reference point, actually outside my set of attributes. I cannot understand it.
But if I know that it is the best, sorry, I will not continue, honestly. I don't want to take everybody's time, but if it is not the idea, if actually I know which one is the best and their order, why I'm going through the decision-making process and I don't put it as direct values? Because if I have already the knowledge, it kind of makes mute the process of comparing them. And I'll let it there. Just a food for thought, nothing special.
Okay, okay, I understand. But if our job finally is to make a ranking of the attributes, I agree with you. But that's not the job. I think we want to understand the relative importance of these attributes, and this is not still the final goal. The final goal is to go and evaluate the alternatives. So this is part of the job, and that part is not even making an order of the attributes, because that has no use most of the time. We want to get the relative importance of those. Okay, but thank you.
Thank you, Elena. Now it's time for Marcel. Marcel Minutolo wants to ask some questions. We are running out of time. So it's only 8 minutes left.
Thank you.
Marcel.
I'll try to be succinct, because I think I understand the point that Elena is trying to make. This is actually when Socrates was trying to determine how it is that you and I share knowledge of a thing, and in particular like a table, and we're talking about a table together. The question was always, how do we both know we're talking about the same thing? And Socrates said there's an ideal form against which we're always comparing the thing we think we're talking about to this ideal form. So in this particular case, I wasn't talking about the attributes, but the ideal form. In AHP, that ideal form will be our goal, whatever it is we're trying to achieve. The attributes are the things that we think make up that ideal form, the thing we have in our head as being like the best, right? This is what's make up the best. The attributes that you're talking about are what we pairwise compare to see how much each of those attributes contribute to this ideal form. And then we rank whatever it is we're comparing with respect to how much each of those attributes are contributing to whatever that ultimate goal is I'm trying to achieve. I think that's what Elena was trying to get at. Hopefully that helps a little.
Yeah, thank you. Thank you, Marcel. Yeah, I understand. Yeah, okay, clear.
Okay, before we leave, I have a question here. I don't know if Kenneth, can you talk, or you want me to read your question? I've seen you there.
Yeah, I'm here. You can't see me, unfortunately. But,
no, I can't see you. That's it.
Which is probably good.
Then go ahead.
Okay, let me pose a question, which is a kind of very random question, I think, in this setting. But we're kind of talking around the subject, and that is that I've done a couple of projects in the past where the executives of an organization, and in fact, in one case, it was the Ministry of Defense, were looking towards solutions to fulfilling requirements. And rather than comparing what the suppliers had proposed as those solutions, what they wanted was a kind of comparison between the perfect solution and the worst possible solution, so that they had, rather than just a comparison between their choices of suppliers or the scenarios of their suppliers, they had some kind of idea of where they sat between the absolute perfect solution, which could only be imagined, and the worst possible solution, which probably just about did the job. So I just wondered whether you'd thought about that or done anything with BWM on that.
Yeah, thank you, Kenneth, for the suggestion. I think this is also very interesting and also somehow connected to what Elena and Marcel mentioned about the ideal BESS and ideal BORs. I think that is something that is also used in the context of TOPSIS and Vicar. I think they create a kind of ideal BESS and ideal BORs by combining the best level of attributes together to make an ideal BESS, and to the worst level of attributes to make an ideal BORs. And of course, it's not necessarily true that we have such alternatives, but they then do a kind of, they use a distance measure to see how alternatives have distance from these two, ideal BESS and ideal BORs. And the idea is to see which one is closer to ideal BESS and too far from the ideal BORs. And based on that, they rank it. I think this is very useful. I think when we again go to the context of considering items as alternatives, but when we are talking about attributes, I don't think that we need that. I think from the set of attributes, at least this is what I'm thinking. It's convenient and possible for a decision maker to think about the most important attribute in making a decision, and usually we have it very clearly immediately in mind when we want to make a decision. I think we know which one is the most important to us. But I think when it goes to the comparison between the alternatives, yeah, I think that's a good idea and has been also used in literature indeed. Yeah, perfect and possible BORs. Yeah, as you named it. Yeah.
Okay, thank you very much. Thanks, Ken. It's a pity we cannot see you. I think it's time to thank you, Jafar, for your nice presentation, especially for all the questions and answers. We've been going through that for 3/4 of an hour, questions and answers. That for sure has been tiring. Thank you again for coming to our conference. You're very welcome. We repeat this conference every 2 years. Whenever you want, you can join us again. Thanks for sharing your knowledge. Thanks for giving us a different perspective of MCDM methods and being so open to answer our doubts. You know, we are a close community and we very much stuck into Tom's method, but we all are interested in other methods and want to learn from you and from
yeah. Thank you, Monica. I always have a great respect for AHV. I think one of the best methods existent in the whole field of MCDA, definitely. And it was really nice talking to all of you. Yeah.
Thank you, Jafar.
Thank you very much, leaving such enough time to ask all these questions.
Yes, that was a pleasure. Yeah. 1 hour and a half of Jafar, that was a pleasure.
My pleasure, same.
Okay,
yeah, thank you
very much. And have a good day. Okay, bye-bye.
Thank you. Bye. Thank you.
Bye-bye.